So we're going to subtract. Am I going too fast? Everybody okay? Making sense? How about edge of pavement to top of curb? Well, we said we're going 6 inches up, so we're going to go plus 0.5 feet. How about top of curb to edge of sidewalk? 5 feet at 1%. Right? We're going to raise up. Let me just double check my math. 5 feet at. Those are now the proposed elevations for everything at Station 10.
And for when you do this, you basically start at the center line and move out, just and then do your deltas.
Yes.
Okay.
Yeah, we're starting at the center line, and because it's almost like a template, we're going to keep always having that same difference. Okay, so how about this? What can we do with that data? So let's do this. Let's go back to get the plan view up here. Let's go back to the survey sheet. So what can we do with this data? Well, we've got to now take these proposed elevations. Let's look at the table headers in here. We've got our elevations, we've got the hubs. We're going to reduce the notes and get all of these existing elevations of the hubs. But now we want to plug these proposed numbers into this, because what are we going to do? We're going to get an elevation of the hub. We've got our proposed elevation. We're going to be able to use the difference. We can calculate the difference. So we've got to kind of correlate what each of these points are. So let's go to flip sheets here. You can do a little sheet flipping here. What's point A? Point A is for the sidewalk, right? Point A is going to be for the sidewalk. Which of these is for the sidewalk grade? It's this one here, right? So the outside sidewalk, the grade that we want to use is 629.86. If I look on the plan view, hub A is that. So let's go ahead and propose the elevation. Let's write down 629.86. Check myself here. Yep. 629.86. Okay. What's B? B's at Station 10. That looks like the curb, right? Mm-hmm. B is the curb. So B, we've got to kind of pick which of these numbers do we want to use for B. We could use top of curb, or we could use edge of pavement, right? Let's think about it. Does the contractor, and we don't know, since now that I know that Jose is working for Austin Tyler, I can Jose can be our man on the street. So if Austin Tyler was going to be in charge of building the curb, and the curb, they're going to build it by itself. It's going to start all by itself. And let's just say out here we have, this is now hub B. That's hub B. We have an elevation on that hub. Does Austin Tyler, this isn't a trick question, does Austin Tyler want us to give the cut fill to the back of the curb? Or does Austin Tyler want us to give it to the edge of pavement? I don't know. I mean, I'm saying, I don't know. Some contractors might want to say, hey, give me top of curb. I'll grade everything top of curb. Some might say, hey, give me edge of pavement. Can we give them either one using this hub based on what we have? We can, right? Because we've gone through and we've calculated both what the top of the curb is, right? And we've also calculated the edge of pavement. So in this case, we could actually, let's just put one. Let's just say top of curb. Let's say Austin Tyler's building the curb. Let's say they want everything top of curb. So our top of curb to back is going to be, what elevation are we going to put in here?
629.7 or 71.
629.71. Does everybody agree with that? Top of curb 629.71. So that's to the top of the curb. Let's keep going here. So what is hub C? Hub C is 10 foot, but that's on the right side. That's on the other side of the road. What's it going to be? Have we calculated it already? We did the left side of the road, right? What do we know about the curb line at the 3% and the 3%? Is it the same? Yeah. It's gonna be the same, right? The road is 8 foot wide on both sides. and it's fallen away at 3% on both sides. So that delta is going to be the same, right? So the top of the curb on the right side of the road is the same as the left. 2971, right? Does everybody see how we got that? Yep. So we can basically take care of whatever we have for that station 10. Now we haven't touched the ditch yet, so here's what I think we're going to do. Let's continue. So now make your table. Let's go down to station 10.50 or 10 plus 50. I'm going to have everyone just kind of work on your own and fill out the rest of the table for the rest of the 10. Now, before you start, let's take a look at something. Do we know we have a typical section where across the road these are all going to be the same? Mm-hmm. We do, right? What happens if I look in the other direction? What do we know about the profile of the road? Say it again, Sam. How about the profile? So if we're going to move from station 10, I'm going to go back to this. We're going to go from station 10 to 10 plus 50. What happens between 10 and 10 plus 50?
1.5.
1.5 feet, right? So we said when I go from station 10 to station 10 plus 50, it drops 1.5 feet. Remember? Mm-hmm. So let's just kind of not even do any math, but let's just look at the numbers of what we've got calced up here. Between 10 and 10 plus 50, this changed by 1.5 feet, right? It's going down this way. If we take 627.95 and I subtract minus 0.24, what I get? 627.71. Mm-hmm. What's the delta between 10 and 10 plus 50 at the edge of pavement? What should it be? 1.50? Because what's happening? Every time we go 50 feet down the road, everything is changing by 1.5 feet, right? The road, the curb, the sidewalk, everything in it. So if you look at these deltas, you can actually, you don't have to go across the section every time. Just what's this delta? 1.50 feet.
Because you already did the original delta.
Right, we did the profile. So all of these are running down the street. So the difference at 10 and 10 plus 50 for all of these should be 1.5 feet. Does everybody see that? Mm-hmm. It makes it real simple. So run your table out for all the way down 10, 11, 50, go all the way down to 12. It's going to follow that same, since we're all working together, why not? So it's less about the numbers and more about the methodology, that everything happening here. So if you want, if you're caught up on the table, you can go through and, I know everyone's kind of just working at their own pace right now. If you're to that point, you can go ahead and reduce the notes, right? So we've got our benchmark here, or we've got our elevation, we got our backside. Has anybody calculated the HI? Or if you're still working on the getting your data in, it's okay.
Yes, 633.77.
Yep, 633.77 for your HI. So that would kind of be the next task that you're going to have, is go through and reduce the notes and calculate all the elevations. Mm-hmm. So how about this? Let's do this. We'll do this as a group. Everybody's got A, B, and C. Does everybody have A, B, and C in their sheets? Mm-hmm. Let's go ahead and just let's reduce the notes real quick here for A, B, and C. We'll just do that as a group, and then we'll come back, because it's going to just be a class. We're just going to keep working on this in class. We can get to the point where hopefully everybody can get this homework assignment done here while we're in class. That's the goal. Mm-hmm. So let's just go ahead, everyone, reduce these three. Let's find out what the hub elevations are for these three. Mm-hmm. So.
So once you get the elevation, the 630.49, would you go to the next foresight and subtract from that number?
So,
Or would you go from the initial height?
yeah, well, right, Crystal, we're gonna keep using the same HI. So this was one setup, and they shot all these points from that one setup. So we'll keep using the HI for that one, yep. So we got those three.
And then your height will change once you go.
Yeah, and let's drop down, because that's what I want to kind of do next. That's good. So you'll fill these in. We'll get the rest of these. Let's drop down to the turning point. So how about we get the turning point elevation? So that's going to be what? 3377 minus 2.79? 633.77, 2.30, 2.79, right? 79. 630.98. 630, 98, 630, 98, and we're not going to have a proposed elevation, so we just throw a line right there. So what's our HI for that second setup then?
How are you getting 98?
I got,
Did you guys get something different?
I got 68.
me too.
633.77. Maybe I typed it in. 2.79 minus.
You're subtracting the height from the turning point.
We're going to go 633.77
Yeah.
minus 2.79. 633.77.
You
Yeah,
said 2.09 or 3.09?
7,
2.79.
Oh, okay, sorry, I'm
Take
doing
that
the wrong
number
numbers.
minus that.
Okay.
Try me again, Manny. It's just you guys tell me if I got the number wrong here.
That's what I
Well,
got.
isn't it the first one? 633.77 subtracting the backside? Or
You would be
subtracting-
the foresight, Manny. You're subtracting the height minus this foresight.
Okay.
So that would give you 630.98. Double check. Punch it in there. Double check me because I'm
No, I think I put it in wrong. I used
Okay.
the backside.
Yeah,
Okay.
Yeah, 30.98.
30.98, and now we'll use it, right? So 630.98. Let's add the backside.
634.07.
634.07. Yep. So with that, we can reduce all the rest of the notes. Sure.
And
Yep.
that's the new height?
Oh my gosh. Sorry for
That's
that.
the new height. Yeah.
That's the new height
And
of the
then you
instrument.
just use that for everything else.
So that's our second setup. So let's do this, and let's jump to the bottom now. So they got all the hub shots here. What's the last thing they shot? They shot benchmark number 2. They got a 3.98. So let's see, what elevation did we get? Well, let's check here. So 634.07, 4.07. Their last shot was 3.98 on the hub. So we shot it at 630.09, but the hub is marked as 630.10. So what's that difference? So that becomes the check. We talk about closing our survey, like some of us did, some of us might have forgotten to do it on last week, but this would be closing the survey. So all of our shots closed, we're at 100th. Pretty good. We're in good shape. Our hub
Acceptable.
elevations are good. Yep. So that's the process. That's the process of filling out the table, reducing the notes. So let's go back up to A, B, and C. So we go to A, B, and C. Let's look at the differences now, because we've got to give them the proposed cut or the proposed fill. So what's going on here? So our hub is at 630.49. The proposed back of the walk is 629.86. So what's the difference between those two? Let's do the math. 630.49 is my hub. I want to put the stuff at 629.63. So if I just come over here, I got 0.63. Is it a cut or a fill?
Cut.
Cut? Who says cut? Cut, cut, cut. Yep. Hub is higher than where we want to put it, so this will be a cut. Let's go to the next one. Now the numbers when the numbers get a little close, it makes you stop and think, right? So our hub is at 629.66. And our proposed grade is at 629.71. It's a fill, right? It's a fill. It's the difference because we're going higher.
C would be
0.05, so it's actually pretty close. Right? So you can see the pattern. So the way to do this is if you take the proposed, I'm going to jot this up here, proposed, minus the existing, whatever that sign is going to tell you whether it's a cut or a fill. So if we took the proposed here, it's higher, it's going to be a plus. You guys see how that works?
Mm-hmm.
Take the proposed minus the existing, use the sign that it is. So let's do the third one together. So let's take the proposed, 629.71. Let's subtract 629.46. So is that a cut or a fill? Fill, right? Because it came out a plus. 20.25? 0.25. So there it is. And everything that we have filled in here is all working for that. So, but we got these gaps. Uh-oh. All right, so everybody okay with being able to get the pavement, curb, sidewalk? We can get all that in, right? It's pretty much this data. All right, we got to deal with this ditch. So let's take a look at the ditch. How about let's do this. Break. How about take a break? Good time for a break. Quick 5. We'll come back. We'll work on the ditch. Yes. Okay.
How did you get the A again?
How did we get?
629.86.
How did we get 629.86?
Yeah.
That would be coming from the table, Jose.
Mm-hmm.
So that was our. Probably got a lot of data on this table now. 629.86 was what we calculated for the proposed sidewalk grade at Station 10. So that would be this number here.
But how did we get it?
How did we get this?
Yeah, because wasn't it 629.45?
How about this, Jose? We started at the center line with 629.45. We have to walk
Oh,
across the section, you see?
yeah.
So this would be walking to get the edge of pavement. This would be walking to get the top of the curb. This would be, where's my sketch? Walking to get the sidewalk grades. That's what the first table does. Do that. There we go. So if we know 629.45 is this, that's what we're doing. We're getting the proposed grades for each of those segments that we walk across. So we got edge of pavement, top of curb, the edge of the walk, and then the back of the walk. You double check because you see how that was the first step in the table. We're basically taking this.
Yeah, I get that one.
You got this part? So yeah, so that's where the 629.86 was. It was the result of us going from each of these points to figure out where that sidewalk is at. Where is that grade? You see it or still not jumping out at you? Okay, and that's why this is one of those assignments that's. How about this? Let's try this.
Because I did the part where the asphalt 3% slope,
Okay.
and it's 8 inches, so you just calculate that and get it.
To get this one, right?
I get that.
Yep. So
Get the curve.
and you get the curb, we went up 6 inches, right? So let's go to the next one then. To get from the top of the curb, to top of the curb to the front edge of the sidewalk, how do we get there? We said we know the parkway is 5 foot wide, and we're going to go up 1%. So we said the park is 5 foot wide. We're going to go up 1%. 5 times that percent, so it's going to go up 0.05 feet. So the rise from here to here is going to be. You see it? And then what? Then the sidewalk is 5 foot wide. It's at 2%. So it's going to go up another 1/10. So that's what we're doing, is we're just adding.
Yeah, that's where I got confused, because I thought we were adding this one.
Okay. Yeah, we're following whatever sign we leave here. You know, the 8% at 3 means we're going down because the cross slope of the pavement's going down. We go from edge of pavement to curb, we're going up, so we're going up a 0.05, yeah, you got it?
Yeah.
So that's why this is helpful, because this is just, makes it automatic, we just kind of follow whatever the numbers we calculated are. So we have a rim. So what can we start looking at? So we've got a ditch that starts here and it finishes here. Can we calculate the slope of this ditch? Everybody say yes we can. Yes we can. What is the slope of the ditch? So how would we get it? We got a high point and a low point. What's the distance of this?
125 feet.
Derek says 125 feet. So we went from 10 to 1125, so 11 plus 25 minus 10 plus 0 equals 125 feet. So what is the slope of the ditch? How would we get that? We got a high and a low, so we've got 625 plus 50 down to the rim of 620. So that equals 5.5 feet. And it's over 125 feet. So what does that come to? 5.5, 125,
0.044.
0.44. So let's leave the math there. So we know that that's feet per feet, but we know that's what, a 4.4% slope, right?
Mm-hmm.
Okay. We can work with that, right? Just like we did here on the profile, this thing is falling at 4.4. So every 50 feet, it's falling at some sort of slope. What if we calculate that real quick? So let's just let's just mock up the profile of the ditch right here. Just make a profile here. So we know this is at 4.4%. So what happens in 50 feet? Let's just do what we did with the roadway profile. So 50 feet, how far does it drop? What do we do? Take 50 feet times 4.4%, 0.044. What do you get? 2.2. Everybody get 2.2?
Mm-hmm.
Sorry, my math is a little sloppy here, but 2.2 feet. So 2.2 feet every 50 feet. So obviously in the next 50 feet, does it again, right? So 2.2 feet. And then how about this last leg? How far is this? This is only 25 feet, right? 1.1. So that last drop is 1 feet. So can we calculate those proposed ditch grades now at the 3 stations? So if I came up here and said, nice here, 629.45. What's my center of ditch at 10 plus 50? 629.45 minus 2.2 feet.
627.25.
I like it. Feet. Everybody got that? I know we're punching numbers here real quick. You everybody see that? How we got proposed ditch? How about the next one? What would it be at 11?
625.05.
Spares. Do we have that right, Manny? Hey, you know what? We gotta take a step back here. Which elevation did we
625.
start with? Yeah.
That's what I was just.
Okay, no, that's good. So this is really 625.50. You got it, Manny?
Yeah.
Yeah. Yeah, so we caught it here. We caught it. That's why we have erasers. That's why engineers love pencils.
Gabe.
Gabe with his micro pens over there.
Yeah.
Gabe just doesn't make any mistakes. That's why he doesn't have to worry. 625.5. All right, so let's take that 2.2. 625.5. 2.2. 623.3. Okay, there we go. How about at 11? Take 2.2 off of that.
621.1.
Yep.
621 even.
Yep, and then we get to check. Yeah, that's what's cool about it. So 621.10 minus that last 1.1 foot, 620 we balanced out there. Good. Does everybody see how we got it? It's a different profile, right? It's a different profile than the road. Okay, so how about this? Work on your own real quick. What's this ditch doing on the other side? Bless you. So we're starting at 622.4. So you could look at this two ways. You could either say 622.4, we know the rim is 620, so I'm pitching down this way. So what? It's going to be doing this. So however you want to attack that. What? It's 100 and... How far is it? 20. It's 50. It's going to be what? 75 feet total? 75 feet total. How far is it dropping? 622.40 minus 620. 0. So it drops 2.4 feet. Still on screen there? Yep. Over 75 feet. So what's my slope? I get 3.2%. So we work the numbers the same way, and however you choose to do it. You could start at 620. You could go out 25 feet here. We know that's 25 feet. How high up do we go in 25 feet? 25 feet times 3.2%? 0.8 feet up. And then what's this? In 50 feet, I'm going up that same thing. So 50 feet, 3.2%, 1.6. We're good. I'll let everybody catch up. Everybody got the ditch grades. This is 625.50. So what can we do with those proposed ditch grades? Where are they going?
And,
Going in the survey notes, right? Find my sheet. I got too many sheets here.
So the proposed elevation would be what they give, right? 625.5.
Would be the start. That would be the high point. So all they gave us was the high point. Oops. All they gave us was the high point of the ditch and the rim. So we just calculated these intermediate elevations.
E and L.
Yeah. So we basically calculated D, E, L, M, and T.
Okay.
So we can put those elevations in here for Let's get a couple in here then. So D is gonna be 625.50. E is 623.30. Tell you what, let's do it as a group. Let's just do these couple here. Let's figure out what's the hub elevation of D and E. Let's punch those up real quick here. 633.77 HI. 2.16. 61. So once you run the cuts and fills out for D and E, so we can see what's going on in the ditch. So we take proposed minus existing and use the sign. And bigger cuts now, right? So our ditch cuts are 6 and 8 feet, so not real deep cuts for the road. Those are pretty shallow for the curb and gut on the pavement, but the ditch has got some deeper cuts. All right, what do we think? Getting it? Everybody okay? Brian, how you doing over there? Got it?
Now, for these down here, are we gonna determine the cut and fill as well?
Mhm.
Or-
Yeah, so the goal of the assignment then is to keep doing what we just did and run the whole table out to get all your cuts and fills. So this becomes the end, that's the end result. So we got a lot done here in class today, which is good. So finishing up the assignment, then that'll be your turn in. What would use for you? All right, let's look at you. Let's look at this at the sewer. So that's the last piece. Let's go to the plan view. So U is what? U is a hub. Let's go over to the description. Sheet here. So U's description is it's a 6-foot offset to the storm manhole at 11 plus 25. And what did they do? They left a rim and an invert. So in this case here, hub U. All right. Up here, this looks like this is going to be hub U. Because what's going on here? Let's just say this is our ditch grade. So what do we have to give the contractor? Hub U says, if I look on the table, we've got to give them the rim and invert cut. So we're going to have, let's just anticipate here. We're going to have a rim. We're going to have an invert. I think we can all agree we're going to have some sort of cut because the manhole catch basin's down in the hole. So how do we calculate that? Let's see what it is. So what do we know? Let's do, what's the elevation of the hub for U? 634.07 minus that 398. Let's just do that real quick. 634.07 is my HI. 3.98 is hub U.
630.09.
630.09. And then what information did they give us about that structure? Let's go back over here. They said the rim, we know the rim is at 620 plus 620.00. So let's just put here, rim is going to be 620.00. We'll just put this here for time being. What about the invert? What's the invert? It's
615.45.
615.45. So let's use our hub and let's use the rim. What's the math difference between them? Proposed 620.0 minus the hub existing 630.09. So I get a cut of what? See what you get.
I'm gonna cut it 10.09.
10.09. Everybody see how we got that? 10.09. And then same for the invert. That same hub is going to be for that 615.45 invert. Big cut there, right? 1465. So if the sewer guy was going to be working to start, he's got to be down 15 feet to get that pipe and that structure in down there. So that's a big deep cut. So anytime, and let's think about this now as we're going through this whole thing. Anytime we have a hub, just like we did out in the parkway in front of the school, we've got catch basins. Anytime we have a hub elevation, we can give anybody anything, right? We can base that on, we can determine where this is in the field. Anybody can tell us where something needs to go, that difference. It's just the difference in the math. So this is how you're now applying, taking the instrument out, setting something up, getting a backside off a benchmark, determining what a hub elevation is. Now this is how you use it. That's how you'll use the information to be able to tell somebody where things go. So in this case, we can tell the sewer foreman, here's where you need to put it. And I got to go to another job. I'll see you later. Let me know if it works out okay. Here's your numbers. Build it. This is where you need to build it. So as a project manager, when you call your survey sub, maybe you're working for a contractor, you now kind of have the understanding. Here's what they have to go through to be able to get the data ready to come out to your job to lay things out. The practical application of this is, you can understand this could be a stressful job, right?
Yeah.
Because you are doing just what we're doing in an office, getting all these numbers together so that you can go out and apply them in the field. So the numbers that we computate here, they've got to be right? So how about this? Want me to give you everybody a little bit of time? You want to crank through and just keep going? Because the last thing let's do that. Let's go till, what time is it?
11:35.
Let's do this. We'll work on your calcs until quarter till. We'll take a little break at quarter till, and then just the last thing is I'd like to show everybody the laser. I'd like just practical application. No FTX today. We'll just do some hands-on on how to use the laser in the Lenker rod. So I'll let you guys keep cranking. You can get your assignment done here if you want. Finish it up. You have your homework done here before you leave class. So yeah. So let's we'll take a break at quarter till. And if you guys have questions you're going through, just shout them out at me, or a number not making sense. And if there's any of my workups you want to see up on the screen, just let me know. I have the table, I got this, and I kind of have this cobbled together ditch profile so I can. I'll leave this up there for now.